object with a velocity u accelerates with a uniform acceleration a from a time t and attain a velocity v. The distance s traveled by the object in the time t is given by s is equals to average velocity times time t, which is equals to half u plus v times t, but v is equals to u plus at. X is equals to half u plus at times t. Therefore, s is equals to ut plus half at squared, equation 2. Also, t is equals to, in bracket, v minus u all over a from equation 1. Then, s is equals to average velocity times time, which equals to, in bracket, u plus v all over 2 times, in bracket, u minus v all over a, which is now equals to v squared in bracket minus u squared all over 2a. Therefore, making v squared our subject of the formula, we now have v squared, which is our final velocity, is equals to initial velocity squared plus 2 times acceleration times the distance, which is now our equation 3. Example 1. A plank is raised at one end in order to form an inclined plane. A light freely running trolley travels from rest down the plane. The time taken to travel from different points to the lower end of the plank are measured and following results obtained. Distance in cm, time. At 0 distance, the time is 0. At the distance of 50, the time is 14. At the time of 100, the time is 2.0. At the distance of 150, the time is 2.5. At the distance of 225, the time is 3. At the distance of 325, the time is 3.6. Draw a diagram to show that the acceleration is uniform and calculations value. Using this value to calculate the velocity which the trolley would acquire at it traveled 400 cm from the rest along the same inclined plane. Solution. Distance is equals to ut plus half at squared, but initial velocity u is equals to 0. Therefore, distance is equals to half at squared. At the distance of 0, the time is 0. The time squared is 0. At the distance of 50, the time is 1.4, and the time squared is 1.96. At the distance of 100, the time is 2, and the time squared is 4. At the distance of 150, the time is 2.5. The time squared is 6.25. The distance of 225, the time is 3.0. The time squared is 9. At the distance of 325, the time is 3.6. The time squared is 13. Now, plotting our velocity time graph, having an interval of 100, 200, 300 on the distance on our vertical axis, and an interval of 2, 4, 6, 8, 10 on our horizontal axis, we will get a very straight line graph where we are tracing the values. And now we have our slope being traced at a point A. Since graph of distance s versus time squared t is a straight line, it means that the acceleration is uniform. Slope is equals to half at, where half a is equals to ab over OB. This is our 225 over 9. A, making A the subject of the formula, we now have 250 over 9, which will give us 50 cm squared. V squared is equals to U squared plus 2AS. V squared is equals to 0 squared plus 2 times 0.5, but U is equals to 0 and S is equals to 400 cm or 4 meters. Therefore, V squared is equals to 0 squared plus 2 times 0.5 times 4, which is equals to 4. Now, V make square going over to the other side will now become the square root of 4, which will now give us 2 meters per second. Deceleration A is equals to velocity change over time, which is equals to 25 over 10, which will give us minus 2.5 meters per second squared. Using S distance equals to UT plus half AT squared. S is equals to 25 times 10 plus half times minus 25 times 10 raised to power 2 will give us 125 meters. Example 2. A motorcycle accelerates from rest for 10 seconds up to a velocity of 20 meters per second. It continues with uniform velocity for further 20 seconds and then decelerates so that it stops in 20 seconds. Calculate A, acceleration, B, deceleration, C, distance traveled. Solution. Acceleration along OA is equals to velocity change over time, which is equals to gradient of OA is equals to AE over OE, which is now equal to 20 over 10, which will give us 2 meters per second. Plotting the velocity time graph using 10, 20 as an interval at the vertical axis along the velocity axis and against time at an interval of 10, 20, 30, 40. We now have the body moving from point O to A, then at a change in velocity, then it has a constant time from A to B before it decelerates from B to C at a change in velocity. Deceleration along BC. Deceleration along BC is equals to velocity over time, which is equals to the gradient of BC, which is equals to BD over DC, which is equals to 20 over 20, which will give us 1 meters per second. C. Total distance traveled is equals to the area of trapezium OABC, which is equals to half AB plus OC times AE. Total distance traveled S is equals to half in bracket 20 plus 50 times 20, which will give us 700 cm. Example 5. A train has an initial velocity of 44 meters per second and acceleration of minus 4 meters per second squared. Calculate the velocity after 10 seconds. Solution. Initial velocity U is equals to 44 meters per second. Acceleration A equals to minus 4 meters per second squared, and time T is equals to 10 seconds. Using V equals to U plus AT, we have V, and substituting the values for the first equation of motion, we have that the final velocity V is equals to 44 plus minus 4 times 10, which will now give us 44 minus 4, which will now give us 4 meters per second. Example 6. A ball is thrown vertically upward from the